is given that a girl swing in a cradle with a time period of pi by 4 seconds. So we can take it as t, we can take it as pi by 4, and with an amplitude a is given as something but 2 meter. A boy standing in front of it blows a whistle of natural frequency, so we can take it as n naught as nothing but 1000. The minimum frequency as heard by the girl is velocity of sound in air, which is given as 320 meter per second. So as the girl is in simple harmonic motion, so when it reaches the mean position, we know that velocity is going to be maximum. So if a source is over here and the observer is moving towards the source with a velocity v, it is going to hear the maximum frequency, and if this observer is moving away from it with a velocity v, it is going to hear the minimum frequency. So the minimum frequency is heard when the observer is moving away from the source. So we know the equation for apparent frequency when the observer is moving away from the source, that is n naught into c minus velocity of observer divided by velocity of source divided by velocity of sound c. So according to the given information, we can write this n naught, which is given as nothing but 1000, and c is given as nothing but 320 minus. We need to find out the maximum velocity of this particle in simple harmonic motion. Maximum velocity, we know that it is omega into e, and omega is 2 pi by time period into amplitude. Over here in question, the value of time period is given as pi divided by 4 into amplitude is given as nothing but 2. So we can let this pi get cancelled. We are going to get as nothing but 16. So the value of v is 16 divided by the actual velocity of sound, which is we can take as 320. So I'll get the value of n, which is 950 hertz.